Hi, I'm Lee Valentine with Xcore Aerospace. Let's show you around the shop here. Let's start with this rocket plane.
Yes, sir.
First rocket plane we built. We built it to test and demonstrate technology. If you come around back here, you see the two 400-pound thrust rocket engines. So this was, we built this about 10 years ago. It was built to show that you can build and fly a rocket plane for not a whole lot of money, and it's built to show that you can fly a reusable rocket plane. So this plane's flown about, I think, 27 flights after the test series, and flies very nice, and costs a lot less to fly than a NASA plane. The nice thing and the key thing about Xcore and the key technology that's needed for cheap spaceflight are long life engines. And that's something that Xcore has and nobody else in the world has. So the engines have to last for thousands of flights. Otherwise, you can't make money. So these small rocket engines were our first reusable ones. They've got many hundreds of engine burns on them, and they're still as good as they were when they were built more than 10 years ago. The next rocket plane we built is not here, but the propulsion system is. So we can work on it here in the shop. We take it out to our test site and bolt it into the ground so it doesn't move. This rocket engine actually looks a lot bigger, but actually the engine itself is only about as big as a Maxwell House coffee can. This structure around here is a containment ring, and it's there for safety. Because if you can't fly safely, you can't fly cheaply. And the reason is, if your engines blow up and you lose the vehicle, they're very expensive to replace. You can't afford insurance, and nobody will want to fly with you if you're doing that kind of thing. So this is a pump-fed engine. The fuel is fed by a pump, which is actually not on this propulsion system right now. The liquid oxygen is pressure-fed. So this was our next step up. I think we have some video we can show you of the flights of the rocket-powered vehicle that used this propulsion system.
Great.
This was the operations and propulsion prototype for the Lynx spaceship, which is mocked up on the floor over there. The Lynx engine is a little bit smaller than this, and we'll take a look at that. But this was the prototype for that engine. People often ask me, well, how high did it fly? And everybody likes to ask that question, but it's the wrong question. The question to ask is, how fast does it turn around? What's the engine performance? And how many times can you fly? Because that's what this was designed to test. We could only fly to about 14,000 feet because it had an unpressurized cockpit. And once you get so and so high, the pilot has to use oxygen. Once you get as high as the thing could conceivably fly, the pilot can't even get by with oxygen, but requires a pressure suit. So this was an unpressurized airplane that this propulsion system was in. We flew it another 40 times after the test series, and we turned it around in 8.5 minutes, and we flew it 7 times in one day.
Okay. So how long does it take to build one of these, and how many people does it take to build it?
It takes more than a year to build one of these vehicles, one of our rocket planes. In fact, we're just starting construction on the spacecraft, and that'll take us about a year to get that built. A lot of the pieces are being built elsewhere. The pumps are in construction in another state.
But it is.
And parts other, yeah, it's all USA. We really can't have foreign suppliers because of legal issues with international traffic and arms regulations. So this stuff is all classified as a munition by the government. We can't talk about it to foreign nationals. So if you look around the shop, you'll see things like State Department orders. So any non-U.S. citizens can't pass that door. Same thing with the machine shop. Same thing with their other. So we pay attention to the law. We don't break it ever. But that prohibits our interactions to some extent with foreign national firms that are doing other hardware for us.
Pretty much. Another over that we stay there.
Okay.
Want to get some of the
Dr. Vito?
Yes.
You're on April.
Hi, I'm April with Space Loft, and I'm here with Dr. Valentine. I'm sorry. Can we do that again?
Yes, go ahead.
Hi, I'm April with Space Loft, and we're here today with Dr. Lee Valentine with Xcore.
Yes, I am a director of the corporation, and glad to give you a tour of the shop today. I'll draw your attention to this scale model of our Lynx spacecraft, which we're beginning construction now. We'll be in flight test in about a year from now, and let's take a look at the shop.
That's very cool. Very cool.
You may wonder what these uprights are here.
Yes.
The uprights show you exactly where the hatch doors open to.
Okay.
So this is so we can make sure when we do our fit tests that things fit through, that you'll be able to get in and out of the spacecraft with a pressure suit on, because you will be wearing a pressure suit for safety purposes. The cockpit is pressurized, but in case there is a problem with its pressurization, there is a backup.
Wow.
So I think this could only sit one person.
No, two.
Two? Oh. Okay.
Here's the second seat here. It's just not in the
Right.
not in the second seat. Actually, is the better seat. It sits back 6 inches here, so that we can make the whole cockpit narrow enough to make the aerodynamics work.
I got you.
So side by side doesn't work with big guys, but this gives us another several inches because the big guy is back here with his big shoulders over here.
Gotcha.
But look around, because these cutouts are completely transparent, and that green part in the front of the spacecraft will be a transparency as well.
Oh,
so
okay.
you can see everything.
Wow.
Got a nice little 360 view of everything.
Yes,
How
you
does it
do.
feel? How does it feel, Josh?
It actually feels quite comfortable. A lot of leg room too.
No kidding.
Yeah, our pilot has, our chief test pilot, Rick Searfoss, flew the shuttle 3 times, shuttle commander, Naval Test Pilot School, fantastic engineering test pilot. But he is a tall guy, and he has legs longer than 95% of the population.
Wow.
So that's made so that we can accommodate big pilots.
Gotcha.
Our other test pilots are also big men. Dick Rutan, if you've ever met Dick, is a big man with long legs.
I gotta say, this is actually very comfortable.
It is a very comfortable, and if you look, it's bigger on the inside, isn't it?
Oh yeah, definitely bigger.
Yeah, that's
Josh, look at me.
That's a
quite an illusion.
trick of physics.
Yeah.
And I'm guessing stuff like this isn't like your typical DVD player.
No, that's the avionics.
Really
a lot of
looks
this,
small.
these instrumentation. There's some unique instrumentation in this that we developed on the earlier airplanes,
Right.
the earlier rockets.
Okay.
So there are some unique instruments, and there are some instruments that you wouldn't find on a typical plane. There's the liquid oxygen level gauge.
Okay.
There are pump pressure gauges that you wouldn't find on a typical aircraft.
And what exactly would I be controlling from this?
That controls the entire attitude of the spacecraft.
Oh.
That is that controls the reaction control system, and it controls the aerodynamic control surfaces
Okay.
on the spacecraft.
Very nice.
So it's standard hands-on throttle and stick,
Okay.
same as a military aircraft. The difference is there's no boost on the aerodynamic control surfaces, so it's flown by the pilot's muscles.
Wow.
Wow.
So you'd have to have a lot of strength to kind of maneuver that.
Not so much as you would think, because we get up out of the atmosphere very quickly.
Okay.
We don't go to Mach 1 till we're above 50,000 feet. So the forces, the aerodynamic forces, are no more than they are on a standard private plane.
Oh, really?
Yeah.
How quickly?
Well, we get to 50,000 feet in about a minute.
Wow.
We hit Mach 1 a little bit above that, so we'll be above the sound barrier, 600 odd miles an hour at that altitude. Then we hit Mach 3 shortly after, just at burnout. 3 minutes into the flight, we're at Mach 3, so a couple times as fast as a rifle bullet.
Wow.
And then a couple minutes more, and we're about 70 miles up.
No kidding.
No kidding.
Wow.
No kidding.
So that's why the pressure suits and.
That's why the pressure suits, because you die very quickly above 45,000 feet without pressure-fed oxygen.
Wow.
Wow.
So